Hello, guys. We have with us Hadi Alhaffar from Miami today to deliver us some amazing talk about design to fabrication. So Hadi holds a master's degree in architecture from Florida International University in Miami. His experience in business development stems from working on an array of both academic and professional projects that require full integration of computational design, virtual and augmented reality technologies, robotics, and innovative business modeling. Hadi has worked on a suite of software and product development projects, co-directing and managing more than 1.3 million in grants awarded by the National Science Foundation. In addition, Hadi's visualization startup has executed over 50 commissions funded by private firms from the architecture, engineering, and construction industry. That's probably why we see really pretty images of their products on our social feed too.
Thank you, Vamsi, for this introduction. I'm really super excited and psyched to see people coming from Germany, see people from India, Belgium, Turkey. This is really interesting and excited. I'm gonna kick off. I'm gonna share my screen. First, I want to start by thanking the Futurely team for putting this together. Vamsi, Eric, and all the behind-the-scenes people. Thank you for inviting me for this talk. I'm going to be representing FRM Studio today. My name is Hadi Alhaffar. And our talk for today is focused on design to fabrication. FRM Studio stands for Forming Responsive Matter. And who we are, we're designers, fabricators, and technologists. Collectively, we've accumulated more than 30 years of experience, digital fabrication, art installation, and design. As I move forward in this presentation, I would highly appreciate if you guys send me your questions as I'm talking, and I'll try to address them as we move forward. Make it more of a talk and less of me presenting, please. So my role in this company is at FRM Studio. I'm the principal and business director. As Vamsi had mentioned, I did work extensively in managerial and directional roles. And I was able to pile up experience when it comes to visualization technology in addition to fabrication technology. Elmer Garcia is our director of design and fabrication. And funny story is, honestly, I met Elmer once at the fabrication lab at FIU. And the way we met is I was trying to fabricate a 6-feet table. It required flip mill CNC. So I go for an emergency. I come back and Elmer had already finished that whole table. So I was like, okay, this guy is up to something. From there, that was 2-3 years ago, and we've been working nonstop ever since. Karam is our director of research and development. He has an extensive experience when it comes to robotics and automation. So Karam's add to the team has always been about, okay, which workflow should we develop? How should we go about it? What type of technology should we integrate? Which I will be covering this as we move forward. At the core of our interests relies advanced fabrication, material processing, structural integrity, robotics, sensor technology, and human-centered design. And when I point all of these out, by no means I'm trying to come across as we're the experts in these domain topics. Rather, we actually had explored and worked in each single area, and we've also combined a lot of them, which you will see in the project that I'll be presenting next. A valid question at this point is, why did we come together, and what are we trying to do? So first, FRM Studio did analyze that there is a gap in the design to fabrication process. There is a gap in the design to production process. And this gap is basically a lot of designers, they fall behind when it comes to materializing and be able to actually visualize and see what their product would look like. Another one that is important is Miami has an appetite for high-end products. There is a big art scene over here. And what we really wanted to do is to have a creative house in Miami that can do design to fabrication. Now, pushing this a notch further, we figured integrating sensor technology with fabrication is at the core of what we would like to do. And Miami does not have a one-stop shop, or it may does, but it does not have that many competition that can execute from design, fabrication, and integrate technology into it. Most important, which is the fourth point, is we wanted a space that is ours, where we can come in, we have our own machines, we have our own tools, we're designers. So we wanted to fuel our passion and interest to do proto-architecture. So what do we plan on doing? We intend to design and produce architectural elements. Those are going to be fueled by science, advanced fabrication, and sensor technology. We want to build furniture products, building systems, that can be cladding systems, that can be, you name it, an art installation. So a valid question also at this point is, what is design versus design to fabrication? So if someone approached me with this question, I'll be like, if what you mean by design is solving functions and laying out a floor plan, I will be like, yes, design to fabrication is totally different. I will be answering design to fabrication in the project that I'll be covering soon. So what do we do, or how do we do it? Actually, not what do we do, how do we do it? This is really important. And those 7 points that I have over here, I'm going to be covering also in the project that I will be showing. But the first thing that we do when a client approaches us is we assess. Is this a good opportunity? Does it line up with our company's vision? How do we go about it? And if we do, and we figure out that, yes, it does line up with the company vision, and we would like to take on this project, we try to offer a solution rather than offering a service. So we try to define what is our client's main pain point, what do they need, and how can we best serve them, rather than just taking on a commission for monetary purpose or whatever other purposes there is. From there, we ideate. That's where we know what the client's need is. We try to combine this with our inspiration. From there, we conceptualize. So we start sketching, diagramming, putting whatever that we think is a good step to move towards a digital model. Once we do so, we start prototyping. We prototype with paper. We prototype with wood. We prototype with 3D printing, you name it, and we prototype. We always like to see it. And the sooner we see the product that we're going for, the faster we can troubleshoot and the more robust this product comes out. Implementing, which is the 7th point, is once you prototype, you want to show it off to people. You want to go take this prototype and give it to your client or give it to your co-designer or friend and get their feedback. See how do they feel about it? What do they think about this? And before you finish the final product, it is highly important that you actually show this to people and collect data back. The projects that I'm going to be covering today are Canopy, Sprout, the Bench, and the KR10. We decided in our company that any project we do, we're going to abbreviate this. We're going to take out the vowels, and that's why you see CNPY. That stands out for Canopy. If anyone has any question, again, please feel free to direct that question, shoot it my way, and I'll try to address it. If not, maybe Vancy and Eric, you guys can jump in and help me if I don't see the chat. Key questions that I would like to answer as I'm also showing this presentation or these projects: what are design constraints? How to define a project's design constraints? How do I leverage design constraints to develop a product? And then how does design constraints become a design intent? Here we see Canopy, and I'm gonna try to go over the 7 points that I mentioned earlier. So the ask was a sculptural piece for a backyard. The sculpture can be enjoyed with friends and family. Scale was requested to be a minimum of 12 feet high. That's 4 meters high, more or less. Placement is for the outdoors. Lights and sensors are a must. That's literally what the client wanted. So for us, when someone says, hey, I want something for outdoors in Miami, that means Miami's weather is hot and humid. Then I need to start thinking, if I use steel, would this work? Do I need to actually finish the steel with something special? Would this work for me? Is it gonna rust after 2 years of operation? Also, Miami is well known for hurricanes. Miami hurricanes are often destructive, and that's a big component because it will big time impact the structure that we will be making or that we'll be doing. 12 feet high, that may require a foundation. It would require engineered connections. It would also have to be modular. Interactivity and light. In that project, we had 250 meters of continuous LED strips. That's 833 feet. So when I say LED strips, each LED strip would require a power supply. It would also require encasement, since this is going to be outdoors. So if I'm saying 833 feet, that would add up to a minimum. And if I was to say like single LED strips, that would be around 100 LED strips maybe, or maybe less, I don't know, but that's a lot. And the actual encasement that we needed would cover the whole foundation of the sculpture itself. Last one is when someone says 5 years, there is a maintenance plan that is needed. There is a lot of logistics that are needed. As I move forward, I also want to disclose that most of what you see here is not my sole work. It's not my own intellectual property. A lot of people have been in and out in these projects, not only the FRM team, but that extends to a lot of people from FIU. We did a lot of these projects at FIU. And I would want to extend actually a big thank you to Samuel Morris, Matteo Stancari. They worked heavily on this project. Julian Ramirez had always been helping us. I mean, some names that I always think of, and they have been amazing help and actually collaborators through our journey up until we started building FRM, and the collaboration continues. In this project, the design intent was very simple. And as I said earlier, this is design to fabrication. So I'm gonna focus a lot less about the design inspiration and the philosophy. I'm gonna focus a lot more on how did we make it happen. So we drew inspiration from trees, their structures. That's how the design came about. If Elmer was here, he would go for a good 30 minutes just explaining his vision while designing this. And what we wanted to do is whenever someone approaches the sculpture, it comes to life. This is what it looks like on a floor plan. The client's house is on the right side, if you guys can see my cursor. On the left side, this was all surrounded by water. I should have updated this drawing, my bad. And then on the opposing side, we had a national park. The main trick was to create this dialogue between a man-made tree-like sculpture and the actual real one. Now, if you look at this drawing over here, we have a concrete pad at the base, sensors and LEDs, they run as channels. Those are in yellow. We have corten, branch and limbs. Corten is a type of steel. So all the branch, the trunk, branches and limbs, they were all projected to be corten. And the foliage at the top is copper. Now, again, my responsibility as someone maybe directing this project or managing this project, when a client says, I want a copper foliage or I want it to look like copper, the first thing that I would start thinking of is budget. Copper is a lot more expensive than if we were to use maybe ionized aluminum. It would give the same exact effect if the intent is to actually get this polished finish. Copper has much more interesting characteristics than just aluminum. It could age, which actually would give this sculpture a much more interesting look. But again, I'm only pointing this out as this is literally what was happening to us. As we were moving forward in this project, every word that the client voiced out, it meant an input towards what we can do and what we can offer. Now, the key question is, how do we build this? And the answer is not to build a 3D model or to actually just maybe 3D print a 3D model. The answer is we got to pin down exactly what did we want to see or what did we want to test from structure, cladding, LEDs, sensors, and power supply. Those were crucial for what we needed. So if you look at the tree on the right side, this is canopy. On the left side, this is sprout. That's the second project that I would like to present. And it's basically the prototype for canopy. What you see here is a simple branching system. The LEDs would wrap all around. So it's very similar mechanism. It's just the intent on the left side was to give our client a piece, a product that he can keep at home and he can be happy about. So our prototype was not just for testing purposes. It was for testing plus to give our client a product that he can show off. What we did is we added a resin paste to the bottom so we can encase all the hardware. This piece that you guys are looking at was interactive. It was motion active and sound reactive. The components, as you can see on the left side, we have flip milled teak wood, extruded aluminum, that was the structure at the center, LED diffuser that goes on the sides, LED channel, so the LED strip that goes in between can actually be sandwiched. Now, this system that you see in front of you, it was, again, designed by the team, but the main intent here was how can we build something fairly quick, but at the same time, we're not designing and making everything. So what is it that I can get off the shelf that can help my purpose, but at the same time, where do I really need to act as a designer? So as you can see in this one, the 3D printed connections were at the corners, and plus it's what connected the extruded aluminum together. That helped us create the branching effect. This was actually designed in-house, which I will show in the next slide. We had the extruded aluminum at the core of what we did, LED channel clamps, and the wood cladding. This is a picture of the 3D print, but now let's go back a little bit. I mentioned that this is for the outdoors. if we're prototyping, we want to as close as we can to what the final product is going to be. So those connections were not printed out of PLA. They were actually printed with a special filament that was best suitable based on our data or our own research that is suitable for Miami. So again, humid and hot. This is ASA. It's very close to APS, but it can take a lot more heat, and it doesn't get ruined with humidity. And again, what we did here was not only to connect the extruded aluminum, but also to create opportunity for the LED strip at the corners to actually wrap around. A video on the left side showing how the cladding system goes on top of the extruded aluminum. But now what I really want to point out on this slide, or like in this whole project, when you have a project that requires CNC milling, you have 3D printing, you have pieces that are from off the shelf that you want to deploy, that's a lot of tolerances that you need to take in consideration. When I 3D print a surface does not have a thickness. So I need to consider that, okay, when I'm depositing plastic that's going to add thickness, what would that look like when I want to put my pieces together? Same for the wood cladding. When I'm CNC milling, there is the actual router pit. Its radius that has an effect for how these two pieces are going to come together. And honestly, again, grateful and thankful to all the team who had actually put effort into this. That was a lot of knowledge and know-how that were compiled over a lot of other projects to be able to execute on this. Now, LEDs and sensors. I did mention earlier that the base had it was encasing the hardware. So we see the wood cladding, the LED channel, as I mentioned, it wraps all around, motion sensor and audio sensor. To see it in action, this is what it looked like. It did not flare down much light. You can see in this one, the cladding is still spaced out. So this was just put on top of it so we can visualize what this would look like. A really important piece of knowledge that I would like to share is going back to tolerances. We did use a caliper. A caliper was integral to measuring anything and everything that we did. And the main reason is the more precise you are, the better your product is going to come out. And also the more understanding you have with the machines and their processes, the more understanding you have with the actual materials, the better your product is going to come out. And that did not solve it.
You can hear now.
Oh, you guys can hear it? Perfect. Well, this is it in action, and that kind of wraps up the first two projects. That takes me to the third project that we worked on. And in this one, there is also a learning curve. This one we call bench. And basically, the main question that we have here is, how important is it to prototype in the design to production or design to fabrication process? Well, we did mention earlier that is extremely important, but I'll try to hit on more as we move forward. The ask was a multi-purpose bench for an event. The event took place at an indoor gallery. They needed a circulation divider. The gallery had one point of entry. We were given 2 weeks to finish this, and the budget was almost non-existent. Did it line up with what we wanted to do? Yes, it did line up. That's why we did it. So the assessment phase, I'm going to take this out. Most of the projects that I'm showing, we did want to do them. That's why we did. So the design constraints when I see something like this is material dimensions and thickness, which I will actually explain this more in a few slides. The final product movability and transportation, that's also something to consider. This is 18 feet, that's 6 meters more or less, which means it's going to require connections and it has to be modular to a certain extent. The biggest probably constraint is the limited production time. This whole project legitimately was produced in 5 days. Ada Diaz on the right side, big thanks to Ada for helping on this project. The intent was to take in consideration affordable materials because of the budget. We decided to use plywood and then piggyback on the plywood idea that it's made out of plies to create this circulation divider. So literally people would come in as we were watching this picture and they would start splitting so they can engage with the gallery's different activities that were taking place. I think this can explain better what I meant by movability. So if I was to count, we have 1, 2, 3, 4, 5, 6, 7, maybe 7 people. And this is Elmer freaking out on the right side. So basically what happened, as we're trying to put this inside the gallery, it did not fit. So we had to twist it, we had to figure something out. But hey, we're no experts, you live, you learn. And that was a learning curve for us. Some pictures, again, going back to, is this how we, I don't know if you guys can see this, but is this how we prototype? So yes and no, it's good so we can see what the surface would look like, but no, as of like, this doesn't give me enough data on how to construct the 18-foot bench. Some pictures so you guys can get a flavor of how it can be deployed or how it can be used. As a process, we literally started this with a surface. So first, you know, we kind of got in the overall that we wanted. We knew we wanted to have a bench, so the bench was on this side, and then the table is on the left side. Now from there, we started breaking this surface into curves. And the main intent was, once we lost these curves, we're gonna have slots. And those slots are what we see in here. So again, the same process, but more in 3D. And what this actually means is our bench was made out of 5 main pieces. So 1, 2, 3, 4, and 5. I think this animation will show it a lot better. This is how it will go apart. That's me on the left side. I think that's how I broke my path. But this is literally how, that's when I deassembled the bench so I can move it somewhere else out of the same gallery that I mentioned. I'm just gonna wait for the top left video so you guys can see how it would come down. I think it took me around 2 hours to break it apart. So when I see something like this and I know I want to make it modular, a big learning curve or a big thing to consider is, how am I going to be making this? We knew we want a CNC mill. So when I want a CNC, my CNC bed size is the biggest constraint that I have. I cannot go more than 8 feet, which is 96 inches. And maybe I'm not going to do metric anymore. So 8 feet is more or less 2.5 meters, I believe, 240 centimeters. So we knew that the biggest piece we have cannot exceed 8 feet. So if I go back one slide before, this piece was the longest we had. And this was the longest period. We could not exceed the 8 feet. This is what one board looked like. This project, we had to use 6 different ones. So what we did here is we nested the drawings using a plugin. And that was an easy, quick solution. So we can get the most optimized layout of our pieces in a CNC, on a CNC bed. Same picture in action. Some of the fabrication pictures, you can see the connections on the right side. And that takes us to my last project that I would like to share with you guys. On this one is basically a project within 6 projects. I was asked to actually set up an inauguration event. What the main intent from that inauguration event for the Robotics and Digital Fabrication Lab is to show off different robotic arm operations. The lab got commissioned a grant, so it got funded so they can get robots. And we wanted to show this off to the architecture community, so this can attract more collaboration and business opportunities to the lab. This is a video that shows what the event looked like. It shows also some of the projects. This will be the one that I'm going to talk about soon. So from a pick and place demonstration to drum pots, clay 3D printing, the actual ribbon cutting happened with the scissors that was mounted on the KR10 robot. So dramatic, I know. A lot of pick and place we did. And I'll move forward. Now, this is the project that I want to share, which is the KR10 dome that we constructed. I put the 2 pictures on the left side so I can share a backstory to this whole project that we started. So initially, the ask was to show off what this robot can do. So from one thing to another, we somehow landed on using Mukarnas as a geometry that we can pick up and assemble in real time in front of people so we can make tables that they can use at the event. But then once we started thinking about it more, we're like, okay, it will be cool to have tables made out of Mukarnas geometry, but how much does it really show off what the robot can do? Honestly, the answer was, it's nice, but it's not going to show off what the robot can do. This robot can move in any direction almost, and it can move 2 meters per second and extremely highly accurate. So this is an Agilus KR10. They're high precision and high speed. The learning curve in this one is the machine precision versus the error that we introduce as humans. We go back to the KUKA manual and we start wanting to map out this robot. And the intent was, if we can map out the work cell, we can demonstrate a pick and place exercise by having the robot pick a unit and place it in a direction that is literally constantly showing off how its work cell operates, or the extent of the work cell. So that would show off reachability, it would show off the speed, and it would show off the accuracy. On the right side, actually, over here, this was the first try of us mapping what the work cell looks like. And when I say a work cell, this is what I'm referring to, this outline at the top. So from there, we figured that using a geodesic dome would be wise. And the main reason why we decided on a geodesic dome, because it's the most structural. It's made out of pentagons and hexagons. So we knew exactly how to break it down into modules, so we don't fall into the same trap with the bench as having to move a giant piece all at once. So we knew we wanted to be modular. On the left side, we can see the jigs that we built. So we can lay steel rods on top, as you can see on the right side. And that's how we did the welding process. Now, another learning curve that we had here is us being naive and wanting to do this, make this happen. We did not know how to weld. So this guy that we see here is the amazing Robert Chambers, a local artist that was willing to help us. So we come up to him and we're like, hey, we made this jig. It's made out of wood. He's like, oops, no. We only had also another, I think it was a week before the event, and we did not have enough time to replace it and build a new jig. Basically what happened is whenever we tried to weld on top of it, it was wood. So it was catching fire. The fire was going up and it will make bubbles. Those bubbles were actually messing up the weld, which I will show in a little bit. It was not too bad, but we learned that moving forward, we will not make our jigs out of wood if our intent is to weld. Now, those are connectors that actually help us put all the pieces together. So when we had the hexagons and the pentagon, those connectors that you see over here are what really clamp the whole thing together. You can see on the left side also the H and the P. The H is for hexagon, the P is for pentagon. So now whenever we want to put the whole thing together, we know how the connection works, which I actually have one over here. And I do want to show you guys what it looks like. Oops. This is it in action. You can see on the right side, the zip tie. That was whenever you zip tie it, it starts coming together. And on the left side, this was another connection that we developed, so it can actually, what would you call it? So it can absorb all the weight coming down. That's how hexagons and pentagons would actually come together using the same connections and zip ties. And as I mentioned, those were made out of steel. So whenever you're using steel, Miami, we had to somehow finish this. So we used car paint. And this is George Maripa on the left side, actually painting those units. Now, we figured out the dome. We figured out how to connect everything together. Our next move was, what would it be placing on top of this dome? What type of units are we going to be making? So we go back again, like I said earlier, we prototype with whatever we see in front of us. We had some chipboard, and those are the ones at the bottom. And we started placing different modules to see what would this look like. Somehow, we landed on making this unit. So we spent a day just designing a unit that we wanted to deploy. We knew we had a steel dome. So we were like, okay, if the robot's going to pick up a unit, how would it place it on the dome? How is this going to clamp on it? So we made openings at the center, and those openings were where we placed magnets. Now, another learning curve in this one, the unit that you see here on the center and at the left side, this took 1 hour, 40 minutes of CNC mill time. We needed 50 of these, and we were at a crunch time. Do you think I was going to let this happen? I was like, no, this is not going to happen. We have to shrink this time back. We have to figure out a way that we can optimize this geometry so we can CNC mill in a much faster pace. We were able, I believe, to optimize the CNC milling time to 40 minutes per unit. Those are the updated units. Big thanks to Nadi in this video, Carl. A bunch of amazing people were just like, honestly, 30 people joined in just to help us put this whole inauguration event. I do have a unit actually in front of me, if you guys can see it. And those are the magnets that I mentioned. And whenever there is a steel, if we were to drop this in front of the dome, it would just clamp directly on it. There is a video that I will show in a little bit. But now, here is the catch. We had the dome, we had the connectors, we had the units. Everything is working out perfectly. We go to do the simulation, it runs also perfect. In my mind, this is what's going to happen. It's going to work perfectly. It's going to be so dramatic, so beautiful. But then, life is too real. It did not work that much. What ended up really happening is, and if you guys can see over here, the unit, the piece, it really had to drop at the center of the rod. The tolerance we had was this much. So if the robot was to be off, it can only be off less than 1/4 of an inch up or down. 1/4 of an inch is, I honestly don't know, probably less than half a centimeter. So we did not have much tolerance. Again, in our mind, we made the geodesic dome as accurate as we could. Those connectors were 3D printed also as accurate as we can. There is no reason for our simulation to be off. Now, this is the first time we run the simulation. The robot seemed to function perfectly fine. It was picking up the units and placing them virtually. But then, whenever we actually had the dome in front of the robot, you can see the gripper, and this is the rod. And it's off. One time it's tilted, another time it's spaced up. What we really figured out, or what we realized, is that, actually I'll go back to this slide, is that the steel units and the units that were dropping on top of it, they were picking up a lot of weight that was making the dome deflect. And whenever the dome deflected, we lost all the accuracy that this robot can actually bring in. And that's, again, that's the learning curve, that we as human beings, our own fabrication, we unintentionally introduced a big error that was not planned for. Now, how do we recover this at a crunch time? Well, we developed a quick end effector that really helped us just go back again to all the intersecting points so we can remeasure and update our script. So we got data from just literally getting these points, updated points, and we took that data and we fed it back again to our script, and now a new updated virtual model came to life. And this is a video of the actual execution. So the robot was picking up the unit perfectly. The only thing we did not like in this simulation was the fact that the dome was moving every time a unit gets dropped. So we had to figure out a way around this, but to be honest, we had no time. Moving forward, if I was to do a project like this again, I think we would make it much heavier at the bottom, a lot lighter at the top, so that we never fall into the same trap. But like as I said, you live, you learn. So conclusion from the project that I showed, we should assess, make sure you always assess an opportunity that comes your way. Don't take it lightly. Try to offer a legitimate solution, not just a service. You can do a service. I'm not opposing to this, but make sure you're offering solutions to your clients. That's how you build a clientele. Get inspired and think. Think materials, think process, think logistics, and think connections. Don't underestimate any of these. Materials are extremely integral to what you're going to be making, just as much as what process would I be using is going to be 3D printed, is going to be CNC milled. Logistics as of, if I was to take this bench, do I take it in one piece? Do I break it apart? And connections as of, what would the structure look like? And last, make sure to plan ahead. No planning, nothing is going to happen. I honestly think the main reason why we've been doing what we've been doing is because we plan, we assess, and we try as much as we can to be as genuine as we can to our clients. That takes me to the last piece of this talk, which is what are we going to be doing with Futurely? And again, big thanks to the Futurely team for this invite. Well, FRM Studio recently had developed this light piece. It's called Monolith, and we are launching a product design course with the Futurely team that is focused on the design to fabrication ideology and how do we go about it. So what we would like to share with you guys is our own journey developing this product. I'm going to be showing some units that we did make in-house from the first prototype that was so crappy, that was literally in 6 different pieces, and how much we learned from doing this into maybe there is the actual piece that is functional, that works, to even maybe 3D printing the actual piece and learning from the material that we use, the type of connections we would need to develop in order for this to happen, developing jigs and understanding, okay, well, if I was to want to bend or create something that is a fascia for my product, what would that look like? How would that work? What type of jig would I be making? We even CNC milled these pieces, which you can see in here. So that's one of the sides of the casing. And honestly, the one that I'm always excited about is our first prototype. And this literally happened. I think we developed this in a matter of 12 hours from idea to having this piece that you guys can see in front of me. I think with this, I conclude. Thank you guys so much for listening. I hope I did add value to your life somehow in a way or another.
Thank you so much, Hadi, for the presentation. It was fantastic to see the work, especially taking a peek into the process of how you guys dealt with all these projects at FRM. Because so far we saw the final results, but it was really fascinating to see the step-by-step and a sneak peek of the challenges that you guys faced in the process. That was really fascinating.
Appreciate it, Vamsi. Thank you.
Yeah. We have a question to begin with from Kaushik on the chat. So Kaushik asks, how do you deal with material wastage? Is something that is considered in the design phase or when you refine the idea to make it manufacturable?
I love this question. And I think like we always have this small fight about me always finding another opportunity for something that we already developed. But to answer this specifically, we are mindful before we start on putting a template for the project. Meaning when we go for a 3D printing project, we got commissioned a 3D printing project not too long ago, and we had to plan ahead. How many hours would this take? How many spools of filaments would be using? And how can we optimize this process? We literally kept like going back and forth to optimize it to the point where we shrunk the printing time from 300 hours to 200 hours. That also impacted the amount of materials we ended up using. So I would say the way we will do it, it's really project specific, but planning is key and also learning from mistakes. So if on this project, I blew off 3 sheets of plywood and I did not need to do so, for the next project, I would already know, I already have data that informed me that we should not do this anymore. So we try to avoid it. The rest of the question is when you refine the idea to make it, yes, I also, through the cycle of the project, we cannot just go to a client and be like, hey, listen, or let me maybe show if I can share again, especially on the bench one. So this took 6 sheets. So on this one, had we not used this nesting plugin, I bet you we would have ended up using maybe 10 sheets of plywood. So knowing also what's out there and how you can optimize your output is also key. I hope I answered. Paula, thank you, Paula. How you approach them? Oh, thank you. What type of filaments would be needed to achieve optimal results during the workshop? That's a good question. So in what we're going to be teaching, we're going to be talking about having a light source, right? So that emits heat to a certain extent. We're going to be showing you guys ways around the actual heat that gets created. We are prototyping using PLA, but we're not going to be advising you guys to only use PLA. We're going to give different options. What we're going to be doing, we're going to show you different ways of casing it with PLA, but at the center, you're going to have another channel that would make you avoid the heat problem. So I would say we're going to prototype with PLA, but ABS is always an option, which will work slightly better since it can take more heat. I'm going to show you guys a defect that happened here. So you can see there, and you can see on this side. And this happened because I left this piece in my car for a couple hours in Miami. I hope this answered. I think also, Vamsi, we had a question from last time. Someone was asking about software that is related to design to fabrication or to the fabrication world. As you guys can see, maybe from my screenshots, we're super heavy on Rhino. Rhino and Grasshopper are great. Grasshopper as a tool, but I don't say that we're solely focused on Grasshopper or computational design. Rhino as a platform, we figured it's always good because uh, you can easily go back and forth with different platforms or different software. Plus, it can be extremely precise, so we're extremely comfortable using Rhino solely, I would say.
Guys,
Thank
if
you.
somebody wants to unmute and wants to ask a question live, just raise your
Please.
hand or just write in the chat and we'll give you access.
Yes. I mean, come on, you guys can have some questions. You don't want to just keep hearing me talk. You know, it's a talk. How to send an emoji? I honestly cannot answer this, but it is a valid question.
Yeah, we will give you the access, SR.
Great. I do want to highlight though, I'll take some time to actually mention this. In the course that we're going to be teaching, we're not only teaching just design to fabrication mentality, that's one, but we're also going to be talking about fundamentals of putting a light lamp. We are going to be covering Rhino as fundamentals and introduction. We're going to be also taking you guys through the 3D printing process. Through all of this, we will voice out what our obstacles have been and how we went through it. One thing to mention is the way that we've been discussing with Futurely to set up this course or future courses is going to always have three main components. One is heavy on thought process. So it could be a business tip, or it could be something that has to do with product development. Two, there's going to be a software workflow. So we are going to be making sure that you guys learn a piece of software. At the beginning, it's Rhino. Then we're going to scale up to potentially Grasshopper. And as we move forward, we're going to start integrating different workflows. Third is a fabrication process. So in the first course, 3D printing, we may carry out with this for another one, but we're open to also teach CNC milling, to talk about integrating a CNC mill piece like we showed in Sprout, putting a CNC mill piece with a 3D printed connection and making this a product that you want to actually sell out or give to your client. How would you describe your experience now using robots as a firm? Main perks, challenges, and thank you. No, thank you guys. Okay, so we are a young startup, so we're not. I don't like to call ourselves a firm, but yes, thank you for doing so. We recently just got a CNC machine. So in-house, we have a suite of 3D printers. We have a CNC machine and a full woodworking station. Now, moving forward, we do want to get a robot, and we have it like so crystal clear in our plans. What we decided to do prior to doing so, we're currently developing our own 3D printer. So the way we've been assessing this as a business, we're always mindful about the way we want to push out or we want to actually use our funds. And we figured if we don't have a demand for a robotic arm, why would we get one in-house? So the way we've been setting this up, we knew we have high demand on 3D printing. We haven't been able to keep up with the actual scale of some 3D prints that we want to do. Thus, what we decided to do is like, okay, we have Karam. Again, he's our amazing R&D. We're like, Karam, can you help us scale up the 3D printing capacity that we have? And what we're going for is 10 times faster, 10 times bigger. A lot of 3D printing happening. Have you also tried printing with carbon fiber? Yes, I love this question. No, I haven't tried 3D printing with carbon fiber. We were actually discussing this, Elmer and I, right before this talk. I was telling him because he bought a bunch of new filaments to the studio. And I was telling him that the extruders that we have are not best equipped to always mess around with different filaments. So something to keep in mind, whenever you want to use carbon fiber, that's going to mess up your extruder. I would highly advise you have a separate extruder only for carbon fiber, and this should be fine, this should work. What type of extruder and specifics, I don't honestly have the full know-how for now, but you can look it up, and that should be easily foundable. Very informative. Thank you, guys. Thank you, guys. Do you design for mass or niche markets, or what is your strategy on pricing? That's also a good question. Thank you for asking this. Like also Vamsi introduced me, business modeling. What I would like to highlight on what business modeling is, we try to, as a startup in Miami, we're trying to explore different business models. And the way we're trying to approach this, we would love for FRM Studio to be a one-stop shop that can do product development, not only product design, but development. Product development includes a much bigger strategy to bring your product into the market. So one is a product that is at this scale. So this is something that we would love to bring ourselves to the market. The second one is maybe bigger products such as the bench that I showed, 18 feet long. That's something that we would like to do a piece or two, maybe on bi-monthly basis. On the long run, we would love to focus on architecture scale, so to actually do cladding systems. And just recently, we're hoping that we will get commissioned a project that we're super excited for. If we get commissioned that project, I'm more than happy to share another presentation, maybe with the Future Lead team, just focus on how we landed that project and also the specifics of how to go about a much bigger project when you're at a startup stage. I hope I answered the question. And guys, by no means, if I did not answer specifically what you're going for, shoot me another question or call me out. But then do you think we could, oh, you already did. Thank you, Muad. But then do you think we could achieve a more efficient setup with a robotic arm over a Cartesian system or a Delta? Good question. Honestly, each one has its perks. I cannot say better or not. I would love to actually have 6 axes and maybe more a rotary table as well. I really cannot give like, yeah, do this better than that. It really depends on the project specifics. If you were to tell me, hey, what I'm trying to do is maybe a bunch of cups, I would say a Delta printer. And if you want to make them out of clay, just buy a Delta printer and keep printing this. But if you were to say, you know what, I want to make a bigger scale CNC milled sculpture and I want to keep making those sculptures, then I'll be like, no, get a robot or find a manufacturer. So that's actually a second point, touching on, do we want to have our own robot or maybe buy another robot or figure this out? I would say, if you can find a trusted manufacturer or someone trusted in your network, someone that you can rely on, I would just do so. You don't have to invest the big buck into getting a robot. Maybe to expand on this a little bit, having a robot that in your facility, getting a CNC machine that requires specific power, that's going to increase your electrical bill, that's going to actually, just the setup for a 3-phase electricity, that's already extremely expensive. So a lot of these, they add up. You would need an electrician. You would need someone to understand mechanical engineering, because any end effector you put on your robot, that's going to add weight. Integrating this with the robot is a hectic process, so on and so forth. I don't know, is there another question here?
Yeah, hi Hadi. I just wanted to thank you for your presentation. It's not, as Vamsi already said, it's not just about the end product. You also give us insights about the process. So there's another question: how does one get started? Because as far as I know, like designing anything inside a computer, you don't know, everything looks perfect. But as you mentioned, when you created the dome, everything looked perfect inside the computer. But once when you actually constructed it, there was this minute error because of the physics, because of the gravity. And so I think that experience you can gain only through actually doing stuff. But as a student or a recent graduate, maybe you have access, but most of the people don't have access to all the robots, 3D printers. And so how do you experiment without purchasing the machine? So how do you get started?
Honestly, it's a little difficult, to be honest, like if I don't have access to machines, but at the same time, and that's part of why we're setting this up with Futurely, it's something that we indeed thought about. If people don't have access to a 3D printer, what would they do? So one solution is, honestly, in today's world, we're extremely connected. So it is totally possible that someone can reach out to FRM Studio and they can be overseas and for us to execute on the 3D printer. I do highly believe that you can find someone in a different location that can execute on your behalf. But most importantly is for you, obviously, to try yourself. So if it's a no and you cannot find access to no machines no matter what, and you cannot get connected to someone, reach out to us and I'll be more than happy to help you somehow in one way or another. Now, on a different note, if the question was also more about how do I get started as of if I want to 3D print or if I want to take my perfect 3D model into something that is physical at this point, I would say prototyping. Prototype, like we said, when I showed the sprout, I said canopy, we wanted to explore 4 different points. That's why we put this prototype in this specific way. But a much better way, if you think that, okay, the experience is not fully there, I would say start with this. Start with the simplest. You can make it out of paper. Once you do it out of paper, you're going to understand, okay, what happens at the bottom, and how would this fold actually make, like, would it make sense? How would I be making this by hand? And then little by little scale up. I would love to show you guys. I mean, it's that I don't have access to them right next to me, but we recently worked with a company on a 6-foot also chandelier. And that chandelier, we went about it from literally a sketch that was given to us, and now, or up until like we wrapped up the project, it was at a fabrication stage. So we went from a sketch, we tried to materialize the sketch as soon as we were able to do so. So we sent a 3D print, we took a look at it, we tried to build a mock-up, a small model to position the actual chandelier, get a sense of what would that look like in front of a person scale. From there, we jumped into, okay, we have a sketch that is physical now that works. How can we take this one notch further? So develop connections, think of different processes. We had, I cannot share now, but I would love to maybe on a different session share with you guys like the true know-how, or like the true way we operate as we go on a Miro board and we break down the project into all the different sections that you would think of, whether it's fabrication, whether it's the 3D modeling, and who's going to be doing what, whether it's if we need a consultant for lighting, who's going to be talking to who, what do we want from them. We voice out all our thoughts that's when we do the assessment. We sit down and we break down the project like literally from A to Z. And when I have everyone on board, we discuss it. If everyone is on board, it makes sense with everyone's time, it's a go ahead. If not, then we go back to the client and we just apologize for it. I hope this answered your question also. The next postgraduate program around 3D printed architecture at IAC, what would be the thing that you'd focus on?
Thank you so much for answering, Hadi.
You got it. I'm glad I'm able to add value or to answer your question. This is, okay, I'm trying to understand the question fully, the next one. As part of the next postgraduate program around 3D printed architecture at IAC, what would be the thing that you'd focus on research-wise to optimize the current process used in the architectural field based on your own experience? So based on my own experience, what I've seen so far is at the architectural stage is 3D printing. Actually, I would say I did have a close relationship, or not, I would say like a good interaction with French technology, which they're doing more, I would say, polymer 3D printing at an architectural scale. I think recently they were also experimenting more to create cladding systems. And also we all have seen 3D printing using concrete. And we all also have seen at IAC specifically, their amazing program, 3D printing with clay. I would say when it comes to clay, or when it comes to concrete, when it comes to all of these different materials, or different materials, honestly, I would say the material is what really needs to be rethought of. It's a lot less about the process and more about material science. Because what's missing is, or what I feel is missing, and that's just my humble opinion, is why are we still using concrete and why are we still using clay if this is maybe a material that has been used like long time ago, whereas we know we have a high-end or high technology robot that is executing. So could this robot use a different material? I would voice out like another company, or like I would name another company that actually did an amazing job really reinventing or thinking of out of the box material, which is, oh crap, I need to remember this. AI Space Factory. I happened to be at Autodesk Technology Center, and I did see their material. And honestly, that was really impressive. It was amazing. It was not clay. I'm not putting down the clay, but, or concrete. I think this should still happen. But if I was myself to lead an effort or to be involved in an effort, I would like to focus on material science and start from there into actually developing a process, rather than really just superimposing a material on a process that we know can actually get stuff done. I hope this answered your question, or this was helpful. Anything else that I missed on? Did I answer everyone's question? I wish I can also see faces, but I don't. And yes, do not forget the promo code. This is active till Sunday. 20% discount on the product design one. We're going to carry out with these courses. And again, like I said, three main points that we would like to cover in every course, maybe a business tip or a product development tip, something that is more focused on software, and also fabrication process. I don't see any more questions, but I do see a lot of names and a lot of amazing people here. Well, Mateos is here, Karam is here, Farah is here. Well, happy to see everyone. Hi, Mateos.
Hey, how are you guys?
I mean, for those of you who don't know Mateos, I mean, I've had the honor and pleasure to also work closely with Mateos. He's a recent graduate from FIU, and he's been killing it.
You're too kind.
Thank you, Jennifer. Also, Karam, if you would like to chime in, Karam is going to be leading the first effort. Again, he's our research and development director. I also see Giovanna here. Oh man, a lot of cool people in this room. Well, thank you guys from everywhere. Whoever jumped in, again, I sincerely hope that this talk was adding value to you guys. If this session did not cover your questions or your concerns, or if you have more questions that you would like to shoot our way, I did have the email address at the end of the presentation, hello@frmstudio.com. Feel free to shoot your questions to the Futurely team. I'm confident they will reroute them our way. Again, however we can add value, this doesn't have to be like at the window of us doing a course. It can be out of it. But yeah, just like let us know.
Thanks a lot, Hadi, for this presentation.
Oh, thank you, Karam.
So excited to see you guys in our course.
I believe they will be excited as well.
Thanks to the FAMC for having us.
Thank you for joining us and doing this with us.
Sure.
We're really happy to have you guys doing this with Futurely, and yeah.
Likewise.
Yes.
I mean, I don't know if you guys can see the monolith. Do you guys see it?
Yeah, we do.
So actually, just yesterday, I haven't showed it yet, but we've been experimenting with some really interesting materials that we will hopefully have them recorded as well. And those materials might be coming my way in a second. I'd love to show you guys a little bit. One thing to say, like I really want to emphasize on this, that through these courses, we're sharing our own journey. We're not experts. We're literally learning as we go. We did actually, I did say, from the projects we've done, we did execute on a variety of different projects with different technologies. And yes, I did post this yesterday, but I'm super excited about this material. I'll try to show you guys a little more, just 1 second. You shoot light from behind. This looks really interesting. So this is one veneer that we'll be experimenting with. Like a bunch of different veneers, basically, that will act as facials for the product. We also will be happy to share with you guys how we source material like this, where we buy it from, why do we buy it from certain places, and kind of the hunt behind finding materials. How complex do you feel it is to develop free-form and curvy products in comparison to discrete assembly in terms of fabrication? It honestly depends. If you were to ask me this question maybe 10 years ago, I'll be like, yeah, that might be a lot more hectic. But now, and one thing that we don't have yet at the studio, but I had the luxury of using before, is resin 3D printing. So there are a lot of different processes that exist today that you could use that can help you get a lot of organic forms that you really don't need to carve out by hand, or I don't know. I think the technology is there. It's not as difficult. Every project has its own logistics. Also, the scale impacts your product a lot. So if it's a big scale product and it's all organic, maybe Mark Fournet with the Very Many, that's a really good example. What they do is next level and extremely interesting. That is complex, but is it doable? Clearly, yes, they're doing it. So everything is doable. It's just how would we go about it? I'll pick up the last question. Yeah.
Okay. Perfect.
I see someone asking, does FRM Studio work on products at a larger scale, like urban design, for example? Urban design is out of our scope. We try to focus on design and fabrication, maybe production. Urban design is a little different than what we would do, but if an opportunity comes in and we want to take it, we make sure to bring the right consultants and the right team and the right people that can actually help us make that effort happen. I do want to thank Vamsi, Arek, Futurely team for giving me the platform, voice out this presentation. If you guys have any more questions, please, again, like we said, shoot them towards Futurely or our way. I'm happy to answer. I hope, again, I added value to you guys, however it is, directly or indirectly. And thank you, guys. I'll be up to now.